Hello everyone. Today we are going to start a very new chapter of class 6 chemistry, which is elements, compounds, symbols and formula. Myself Suman Singh. So today we are going to start this chapter, okay? So when we talk about this chapter, I hope you have learned chapter 3. Okay. So in chapter 3, what you have seen that in the chapter matter, you have seen that all substance is made up of matter, right? All the substance which is present in the nature is made up of matter, right? And on the basis of this, what we have done, we have, on the basis of its state, we have divided the matter into solid, liquid and gas, okay? Although they may contain same kind of matter, so we have divided this into solid, liquid and gas, okay? So for example, as you can see, one example is given here: water, water water vapor, okay, and ice are three states of same kind of matter. Means what? When we take water, okay, water or water vapor or or ice, if if this water vapor is cooled down, then it will convert into water, right? And if is ice is warm, then it will convert into water, right? So both three are same, but their states are different. Ice is solid, water vapor is gas, and water is what? Liquid, right? So I hope you have understood this. Now when we talk about the classification of matter, so classification of matter can be done on the basis of the similarities, some similarities and dissimilarities in the chemical composition, okay? So when we are asked to define the class, or when we are asked to classify the matter, so matter we can classify into their on the basis of their similarities and dissimilarities in the chemical composition, okay? So some example is given here, you can say. For example, salt and sugar, both are what? Solid, but they are different from each other because they are made up of different kind of atom, right? Because if you have seen, when you will taste salt, it has a different taste, and when you taste sugar, it has a different taste, right? Now again, when we say talk about the water and oil, both are liquid. As we can see, oil is in which state? Liquid state, right? And water is also liquid, but they are different from each other. Oil is different, water is different, right? Now next is what we can say: the substance made up of only one the substance made up of different kind of matter may be pure or impure. Means whatever the substance which has made up of different kinds of matter, it may be categorized in two form, which is pure and impure, okay? So pure is what? Impure or impure, or homogeneous or heterogeneous. Homogeneous means what? The substance or the mixture in which the constituent particles are uniformly distributed. Or you can take heterogeneous means what? The constituent particles are not uniformly distributed. I will give you one example of homogeneous and heterogeneous. Suppose we have this container, and in this container, what we have done, we have in this container we have taken a mixture of suppose salt and water, okay? We have in this container, we have taken a mixture of salt and water, okay? Here this, suppose this is a mixture of salt and water, and what we have done, we have taken another container, okay? And in that container, what we have done, in that container, suppose one more container we have taken here. Okay, this is another container, and in this container also we have taken some solution. Okay, we have taken some mixture, and here the mixture is of, here here we have taken what, salt and water, right? Here what we have taken, here we have taken salt plus water. Okay, and suppose here what we have done, here we have taken sand and water, sand, water, right, and mud. Okay, so what we will see, when you will test this, when if you will dissolve this salt in water very nicely, then what we will see, when you will test the salt from this side or from this side or any from where anywhere, if you will test, you will feel the same taste, right? But when you will see, you will not taste this one, right, because it is sand, right? So when you will see this, you will see that in some particle, in some places of water there is more sand is there, in some area mud is there, in some area water is there, means here the composition means sand and mud are not uniformly distributed in the water. So this type of composition is called what, heterogeneous mixture, or this type of mixture in which the constituent are uniformly distributed is called homogeneous mixture. Okay, I hope you have understood what is heterogeneous and homogeneous. Okay, now next is what we can say, a substance in which some other substance are also present in smaller amount is called impure substance. Impure substance, or we can say that if we are taking here, again one example I will give you for impure substance. Suppose we have this container, and in this container, suppose we have in this container, suppose we have this is suppose a mixture of any. Okay, suppose this is a mixture of something like we can take this is a mixture. Okay, and this mixture is of, suppose this mixture is of sugar. Okay, suppose this mixture is of sugar and water. Okay, sugar and water. Then after that, what I will do, if I will add here sand, then what will happen, this will become what, impure, right? So that is why it is written here, the substance in which some other substance are also present in smaller amount is called impure substance. Okay, now for to check, how we will check the purity that the following substance is pure or not. So to check the purity of the substance, we can take, we will we will measure the properties, such as here it is given. So we will measure the properties like color, taste, melting point and boiling point, density, etc. We will measure that. Okay, so by measuring this thing, we can get, and we can easily identify which one is pure substance or which one is impure substance. Okay, now next is, one by one we will see what is pure substance. So when we talk about the pure substance, a substance of a definite composition which has the constituent particle throughout is called pure substance. Means what, in which the constituent particles are same. Okay, and we can say the constituent particles are same throughout. Okay, that type of substance is called pure substance. So pure substance is also of two type, one is element and another one is compound. So what is element? We know that hydrogen, helium, lithium, beryllium, boron, carbon, these are all what, these are all elements. Why these are called element? Because if we are breaking the gold, suppose we are taking the gold is what, all of I hope all of you have seen gold, right? So if we will break the gold, it will only if we will see the composition of gold is made up of only one kind of atom. Okay, which is gold atom. Okay, when if you will break that gold, we will not get any other element. Okay, we will get only gold. That is why the element is what, since, because why this that is why it is called element. Okay, So we can easily define like this: element are made up of only one kind of atom. Okay, element are made up of only one kind of atom, and the composition and the compound is made up of only one kind of molecules. I hope you know what is atom and molecules, right? Next is, they in a pure substance, the composition is uniform. As you can see, in a pure substance, the composition is uniform, okay, throughout, and we can say that it is an homogeneous, right? I have given you the example of homogeneous, right? Next, they have a definite set of physical and chemical property. Means what? Their physical and chemical property will be definite or may be fixed, okay? And next is what we can say: they have a fixed melting and boiling point. They have a definite specific gravity, and moreover, they have the pure substance as a characteristic color, order, and taste. Okay, they will have a definite color, and they will have a definite taste, and they will have a definite character. Okay. Now, again, what we can say: pure substance cannot be broken down into a simpler substance by any physical means, because by any physical means you cannot break down the pure substance. Just in the case of water, if we are taking water, is what? It is a pure substance. Okay, so I will give you example. Water is what? It is a pure substance. When we will see the boiling point of water, it is fixed, which is 100 degrees Celsius. If we will see the freezing point, it is fixed, it is 0 degrees Celsius. Okay, in some common salt, if some common salt is mixed in it, the resulting solution boil at the higher temperature and freezes at a lower temperature. This means that it has a some impurities. Okay, means what we can say: I will tell you like this. Suppose at that time when there was not having a salt in the water. Okay, at that time, suppose this is a water, in this container there is a water, and in this container also there is a water. So what we have done, we have started to heat this container. Okay, and we have started to heating by we have started to heat this container. Okay, so what we have done, but we have changed little bit here. There is a pure water only. Here is pure water. Okay, here is only I have used only pure water here. Okay, I have used here pure water only, pure water, H2O. And but here what we have done: H2O plus some salt. Okay, we have added some salt. So what will happen at that time? Its melting point was what? Boiling point was what? 100 degrees Celsius, right? 100 degree Celsius. Okay, and the freezing point was 0 degrees Celsius, right? But when we add here in this water, when you will add some salt, the melting point will change. Okay, it will become greater than 100. Okay, sorry, it will become greater than 100. Okay, and the melting point, freezing point will also become will also change. That is why it is written here: if if some common salt is mixed in it, the resulting solution boils at a higher temperature and freezes at the lower temperature. This means that it has some impurities. That is why its composition has changed. Okay, so I hope you have understood this. Now, when we talk about the elements, there are millions of substances in this world. Okay, but they all are made up of a limited number of substance. Okay, and this basis substance is called element. Means what? You can see there are loads of substances are there in this world. Okay, but these all substances are made up of some basic elements. Okay, some basic substance. Okay, which is called element. Just like oxygen, you will get so many compounds of oxygen. Okay, for hydrogen you will get so many compounds of hydrogen, you will get so many compound of nitrogen, you will get so many compound of carbon, so many compound of copper, silver, iron, gold, tin. So you will get so many compound of these metals. But the basic is what? Oxygen. Oxygen is what? Oxygen is an element. But if you talk about H2O, it is a compound. Okay, or if you talk about H2SO4, so in H2SO4 it is what? Sulfuric acid. But the hydrogen, sulfur, okay, and oxygen which is present in H2SO4, it is what? Is an element. It is an element. Okay, so there are millions of substance in this world, but they are all made up of limited number of basic substance. Okay, and this basic substance are what? Element. Okay, and I hope you have understood this, what is element. Now, Scientists have so far, when we talk about the element, so far 118 elements have been discovered. Okay, so when you will see the periodic table, okay, so there you will see that the scientist has so far discovered that 118 elements they have discovered. Okay, and out of that 92 are found on the earth, okay, which was found on the earth crust. As you can see, everything is written here. Scientists have discovered so far 118 elements, out of which 92 are found in the earth, which occur in nature, in the nature, like in the rock, soil, or air or water, and the remaining 26 they have been artificially created. Means the scientist has artificially created 26 elements. Okay, and the rest 92 is from the nature. So how we can define element? So it is very nice definition is given in your book. As you can see, an element is defined as a pure substance. Okay, as you can see, an element is defined as a pure substance made up of only one kind of atom that cannot be converted into any simpler than itself by any physical or chemical process, right? What does it means? That if it is an element of hydrogen, by any process, by any means, we cannot change that hydrogen into oxygen. It will be hydrogen. Okay, if it is an oxygen, or if it is a nitrogen, if it is an oxygen, by any means we cannot change oxygen into nitrogen. Okay, it will remain oxygen only. What we can do, we can convert oxygen into carbon dioxide, or we can convert oxygen into uh, ozone, or we can convert oxygen into carbon monoxide, but we cannot convert oxygen into nitrogen, oxygen, and nitrogen, chlorine, like this. Okay, now next is on the basis of their properties of the element. Elements are classified into metal, non-metal, and metalloids. Okay, so what is metal? So we will see one by one what is metal. This one, metal is what? Metal, most of the element known to us are metal. Okay, just like gold is what? It is a metal. Silver is also a metal. Iron is also a metal. Okay, aluminum is also a metal. Zinc is also a metal. Magnesium is also a metal. Lead is also a metal. Calcium is also a metal. So what is the properties of the metal? So first of all, first property is metals are usually shiny. Okay, as you have seen, gold very shine, it shine very much, right? Gold, aluminum, copper, you have seen that, right? Zinc, it shines. So metals are usually shiny, or means we can say lustrous in nature, except we will see that sodium metal is not shiny. Okay, it is you will see in the higher classes, in class 11 and 12, when you will do the experiment. So at that time you will show the sodium metal, so it doesn't shine. Okay, and it is a very dangerous metal. Okay, now next is they are solid. Most of the metals are solid. As you can see, most of the metals are solid. Okay, most of the metals are solid. Okay, except mercury, which is liquid. Mercury, you have seen, I hope all of you have seen thermometer, right? From where which we used to see our temperature when we are suffering from fever and all. So in that liquid, in that thermometer, there is one liquid is there, that is actually not a liquid, it is a mercury. Okay, mercury is what? It is a only so metal which is liquid. Okay, now next is they are ductile. Ductile means what? They can be drawn in or stretched into a thin wire, the wire which we use in our house. Okay, you have seen that wire is what? This is a metal. And why? What is the property from which it has been drawn? Means it is a ductile, that is why it has been drawn into a wire. Okay, we cannot draw wood into a wire, can we? No, no, right? So since this metal has a ductile nature, that is why we can be drawn into or stretched into a wire. After that, it is a malleable also. Malleable means what? Which we can convert into a thin sheet, beaten into a thin sheet. Thin sheet means you can see the tin which we use in our house for the roof. That is what? That is metal, right? So how it has been made? It has been beaten into a thin sheet. Okay, why it is because it is malleable, right? Except zinc, where zinc is not malleable. If you will beat the zinc, it will break. Okay, just like the non-metal or any other non-metal. Okay, so I hope you have got some idea. You have got some idea of metal. And now, next is, they are generally good conductor of heat and electricity. Okay, they are generally good conductor of heat and electricity. This is a very common example you have seen in your house, right? How this metal are good conductor of heat and electricity, because the utensils, whatever the utensils we are using to cook our food, these are all what, we are all generally from metal, generally made up of aluminum, right? So these are all what, metal. Okay, so because this is a, it used to conduct heat, because when you will see, when we will put any pan on a frying pan on a gas stove, what will happen after some time, the heat will spread throughout the pan, right? So why it is like this? Because this is a good conductor of heat. Metals are good conductor of heat. Now again we will see one example, the electricity, good conductor of electricity. The wire which we are using, it is a metal, right? So it is conducting electricity. That is why that is why we can transport electricity from here to any other place, right? So that is why it is a good conductor of heat and electricity. Now next is, they have a high melting and boiling point. They are having very high melting and boiling point. They cannot be easily melted. That is why we are using it for to cook our food, right? Otherwise, if any, in place of that metal, if we are using plastic, then it will melt, right? So that is why we use metal to cook our food. Okay, now again, they produce a specific sound when struck. They are sonorous. They are sonorous, and when they are struck, they will produce sound. If you have the scene in a temple, that in a temple, when you will see what we say, the bell, you have seen in a temple the bell, right? So when the bell is beaten, it produces sound. Or in a school bell, you have seen, right? When it is beaten, it used to produce sound. So what is that? This is a metal. Okay, and it is a property of the metal. That is why it is producing a sound, right? And this property is called sonorous property. Okay, since metal are sonorous, that is why it used to produce sound. And you have also seen in our home, if our utensils fall from a height, it produces sound, right? Why it is producing sound? Because they are sonorous. Okay, so I hope you have understood what is metal. So now next is non-metal. So what is non-metal? These are these are the element with a dull surface. Okay, they have a very dull surface. Okay, they do not shine, just like the metal. They do not shine, except iodine solution. If you have seen, if sometime we get wounded, so at that time the nurse or a doctor used to use one black color liquid, right? It is an iodine solution. Okay, so iodine and carbon, iodine, that used to shine. Another one is diamond is also a non-metal, but is to used to shine. And the graphite, which is used in our pencil, the black one, this is also it also shine, right? So except these two, diamond, graphite and iodine, all the non-metals are not shiny, right? Next, they are less in number as compared to metal. As we know that metals, we have large amount of metals, but non-metal is very less. Okay, and non-metal are either soft, solid, or maybe gases. Okay, soft solid means sulfur, phosphorus and iodine. These are all what, soft solid. Okay, after that, when we talk about the gases will be oxygen, nitrogen, hydrogen, chlorine. These are all what, these are in the form of a gas. Okay, and bromine is the only liquid non-metal. Means what we can say like this: the non-metal found in three state: solid state also, liquid state also, and gaseous state also, right? In the gaseous state, you will get oxygen, nitrogen, hydrogen, chlorine, right? These are all what, these are non-metal. Okay, after that, in the solid state, we will get sulfur, phosphorus, iodine. These are all what, solid state non-metal. And again, after liquid state, in liquid, only one is there, bromine, which is the only liquid which is a non-metal. Okay, after that, we can also say that the carbon exists as a solid, like charcoal, coal, graphite, and a hard solid like diamond, right? Next, when we talk about the non-metal, non-metal cannot be drawn into a wire just like the metal, or it cannot be drawn into a sheet. Okay, because it is not ductile and not malleable. Okay, and they are mostly brittle in nature. If brittle means when we will hit that non-metal with with any hammer, it will break, right? It will break into smaller and small pieces. Now next is non-metal are bad conductor of heat and electricity. It will not conduct electricity except graphite. Don't never use that graphite, or never use that graphite for that graphite which is there in your pencil is a good conductor of electricity. So keep away that graphite or pencil away from the electric sources, okay? So that used to conduct electricity. Now next is they have low melting and boiling point, okay, except diamond and graphite which has a very high melting and boiling point, okay. Now next is they do not possess sound when it is struck, as in the case of metal. When it was struck by any other metal, they used to produce sound, right? But here they will not produce any sound. Now next is what? Metalloids. So metalloids are between metal and non-metal, okay, and these are the element which are neither metal. They are neither metal nor non-metal, okay, and they sometimes they show the properties of metal and sometimes it show the properties of non-metal, okay. So non-metal metalloids are solid, okay, they are generally solid. Some of the metalloids are given here, you see: boron, silicon, arsenic, antimony, germanium, thallium, and polonium, right? These are all what? These are some of the non-metal, okay. Now next is noble gases. So what is noble gases? Noble gases are, these are the generally gases, okay. These are gases element, these are element as well as gaseous, okay, and they do not react with any other element, okay. They are chemically inreactive, means they will generally they do not react with any other element, okay. As a result, what we that is why as a result it is called what? Inert gases or noble gases, okay, and they are found in an atmosphere in a very less quantity, okay. Some of the example is some of all the example is there. This much is only noble gases, right? Helium, neon, argon, krypton, xenon, and radon. So this was all about your uh, inert gases, okay. So why it is called inert gas? Because it do not react with any other because it does not react with any other element, okay, and that is why it is called inert gas. And these are found in an air in a very small quantity, okay. And what are noble gases? These are helium, neon, argon, krypton, and xenon, and radon, okay. So I hope all of you have understood this, okay. So we will keep up to this. In the next class we will start with the symbol of element, okay. Till that, thank you.